Welcome to Lucid Mind Chemistry channel. In this video, I'll be solving Chemistry A-Levels multiple choice questions. Paper 11 from October-November 2021. For question timestamps and other useful information, please visit video description. Question 1. The mass spectrum of a sample of neon is shown. The relative abundance of each peak is written in brackets above it. This is the relative abundance of first isotope, this is for second isotope, and this is for third isotope. What is the relative atomic mass of this sample of neon? We are going to use the formula. Relative atomic mass is equal to sum of mass into relative abundance. This is done for all isotopes and they are added together divided by sum of relative abundance. So putting values for first isotope, the mass is 20, the relative abundance is 100, so 20 into 100 for first isotope, plus 21 into 0.3 for second isotope, plus 22 into 8 for third isotope. Divided by the sum of relative abundance, we have 3 relative abundance, 100 plus 0.3 plus 8. By calculating, the value of relative atomic mass comes equal to 20.15. Correct answer is therefore A. Question 2. 2.0 grams of ammonium nitrate decomposes to give 0.90 grams of water and a single gas. What is the identity of the gas? Let's write the equation for the decomposition. We have ammonium nitrate. It decomposes to give water and single gas. Now we have nitrogen and oxygen that is left. So it consists of nitrogen or oxygen. We do not know the values for nitrogen, how many atoms of nitrogen or how many atoms of oxygen are present. It could be NO2, it could be N2O or NO. Now we can find the molecular mass of ammonium nitrate. We have 2 nitrogen atoms, so 14 into 2, it is 28. Plus we have 4 hydrogen atoms, plus 3 oxygen atoms, so 16 into 3. It comes equal to 80. Now we can find the number of moles of ammonium nitrate by using this mass. Number of moles is equal to mass in grams divided by mR. Putting values, mass in grams is given, it is 2. mR is calculated, it is 80. So number of moles of ammonium nitrate is 0.025 moles. They've also given the mass of water. Water is H2O and mR is 2 plus 16 equals 18. Now we can also find the moles of water that are formed. Using this formula again, we have 0.90 grams divided by 18 for water. Now it comes equal to 0.05 moles. Now we can use the ratio of these moles to find the balanced number of moles. We have ammonium nitrate and water. Moles of ammonium nitrate is 0.025. For water we have 0.05. Now dividing by smallest value on both sides, we can get 1:2. It means that if we have 1 mole of ammonium nitrate, it forms 2 moles of water in the balanced equation. Now we can see we already have 1 mole of ammonium nitrate, so we can write 2 with H2O according to this ratio. Now let's balance the rest of the equation. We have 4 hydrogen atoms that are balanced. 2 oxygen atoms are also balanced. So we have 1 oxygen left. 2 nitrogen atoms are also left. So this product should be N2O. Correct answer is therefore C. Question 3. Which of these elements has the highest fifth ionization energy? Now, ionization energy is the energy that is required to remove an electron from the outermost shell. Now, we have fifth ionization energy. It means it will be the ionization energy required to remove fifth electron. We have carbon, nitrogen, phosphorus and silicon. Let's find out the atomic numbers. From periodic table, carbon is 6, nitrogen is 7, phosphorus is 15 and silicon is 14. Now let's do the electronic configuration. We can write suborbitals 1s, 2s, then we have 2px, 2py, 2pz, then we have 3s, then 3px, 3py and 3pz. First one is the carbon. There are 6 electrons, so 2 in 1s, 2 in 2s and 2 in 2p. Second one is nitrogen. 2 electrons in 1s, 2 in 2s, 3 electrons are in 2p. Third one is phosphorus. 1s2, 2s2, then we have 2p6, 3s2, 3p3. And for silicon, 1s2, 2s2, 2p6, 3s2 and 3p2. Now let's remove 5 electrons from each. 1, 2, 3, 4 and 5. Now fifth electron for carbon is removed from 1s orbital. 1, 2, 3, 4, 5. Fifth electron from nitrogen is removed from 2s orbital. 1, 2, 3, 4, 5. In p it is removed from 3s. In silicon it is removed from 2p. Among these orbitals we know that 1s is the one that is nearest to the nucleus, so therefore highest fifth ionization energy will be from 1s. So therefore answer is A. Question 4. The ion X+2 has the same electronic configuration as atom Ka, krypton. What is the electronic configuration of an atom of X? From periodic table, the atomic number of krypton is 36. We can do the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 and 4p6. It becomes 36 electrons. They have given argon with each, and we know the atomic number of argon is 18. So we can count 18 and we can write argon instead. So this portion can be replaced by argon. Then we have 4s2, 3d10 and 4p6. This is for the atom of krypton. It says that this electronic configuration of krypton is similar to the ion X+2. So it is equal to X+2. Then what will be the electronic configuration of X? As we know that from X+2 to make X we need 2 more electrons, or we need to add 2 electrons. So we are going to add 2 electrons upon this side. So the electronic configuration will become argon 18, 4s2, 3d10, 4p6 and 5s2. 2 more electrons are added. So the correct answer is therefore B. Question number 5. Which type of interaction exists between water molecules and metal cations in aqueous solution? Now metal cations is positively charged, and when it is dissolved in the form of aqueous solution, what happens that water molecules surround these with the help of partial charges. Oxygen is partial negative, hydrogen is partial positive. So in this way, dissolution occurs. Similarly, negative ion is surrounded by H plus ions of water molecules. First one is dipole-dipole interactions. As we can see, there is a dipole in water, but there is no dipole in cation. Only single charge is present, so therefore this is incorrect. B is hydrogen bonds. Now hydrogen bonding takes place between partial positive hydrogen and electronegative element like nitrogen, oxygen or fluorine. In this case we have cation, so therefore this is also incorrect. Third one is ion dipole interactions. Now we can see that we have dipole in water and we have ion, that is cation, present, so therefore this could be correct one. Part D is ionic bonds. Now this is not ionic bond, as ionic bond is present in solid ionic compounds. Correct answer is therefore C. Question 6. Which substance shows the greatest deviation from the properties of an ideal gas under room conditions? Now we can say that ideal gas is that gas which has lowest molecular mass value and which has least forces of attraction between the molecules, or no forces of attraction between molecules. It means that the gas that will show deviation must have higher MR values and most forces of attraction between molecules. In carbon dioxide we have carbon, which is 12, and oxygen is 16. 16 to the 32 plus 12, it becomes 44. Hydrogen is 2. Neon has atomic mass of 20.2. And ammonia is 14 plus 3 hydrogen, 17. Second thing is that we have to find the forces of attraction, as CO2 molecule is linear. We have partial negative oxygen at 180-degree bond angle, so therefore dipole moment is 0. Second one is hydrogen molecule. We have no partial charges, as both are the same, so therefore again we have 0 dipole present. Neon is noble gas and it consists only of neon atoms, so therefore it is nearest to the ideal gas situation. Again no dipole is present, so we have 0 dipole. Last one is ammonia. We have nitrogen, lone pair of electron is present. We have 3 hydrogen atoms. Nitrogen is electronegative, so it is partial negative. Hydrogen is electropositive. Now we can see that as we have nitrogen, so therefore hydrogen bonding can also take place. This hydrogen atom of one ammonia can attract nitrogen atom of another ammonia molecule. So among these four, strongest forces of attraction are present in ammonia, which is hydrogen bonding. As well as we can see there is dipole moment present, and the dipole moment of ammonia is 1.42 dBi. This is because nitrogen is partial negative and hydrogen is partial positive. And on one side of molecule we have negative charge, while on other side of molecule we have positive charges. So among these four, ammonia will show the greatest deviation from ideal gas. Question 7. In order to determine the enthalpy of neutralization of a strong acid and strong alkali, 25 cm³ of 2 mole per decimeter³ sodium hydroxide, which is strong alkali, is added to 25 cm³ of 2 mole per decimeter³ hydrochloric acid. This is strong acid. The increase in temperature is 12 degrees centigrade. In a second experiment, the same method is used, but 50 cm³ of 2 mole per decimeter³ alkali, sodium hydroxide, is added to 50 cm³ of 2 mole per decimeter³ hydrochloric acid. What is the increase in temperature in second experiment? They have given the rise in temperature in first experiment, delta T, which is 12 degrees centigrade, and they are asking about the same in second experiment. Now you should remember that for enthalpy of neutralization of strong acid against strong base, the enthalpy change value is always constant. This is because all strong acids are completely ionized into solution in the form of H+ ion, and all strong bases such as alkalis are completely ionized in the solution to form OH- ions. And enthalpy of neutralization is actually the presence of H+ and OH- to form H2O. So for all strong acid and all strong bases, the enthalpy of neutralization will be same, and enthalpy of neutralization is negative as heat is given out. Now in the question we can see that the concentration of HCl is same on both sides. The concentration of sodium hydroxide is also same on both sides. So therefore same concentration means same number of H positive and OH negative ions. So therefore enthalpy change will be same. So therefore the change in temperature or the increase in temperature should also be similar. So answer is B. Question 8. Which equation represents the enthalpy change of atomization of iodine? Now the definition for enthalpy change of atomization is when 1 mole of gaseous atoms is formed from the elements in their standard states. Under standard conditions. Now we can look into the options. We have 1 mole of gaseous atom being formed in the first one. We have 1 mole of gaseous atom formed in the third one. In B and D, 2 moles of gaseous atoms are formed, so therefore this is incorrect. Now looking at the elements in their standard states, we know that iodine is solid in its standard state, it is not gaseous. Also the equation is balanced, so therefore answer is C. Question 9. Zinc atoms can be oxidized to zinc plus 2 by dichromate 6 ions in acid solution. Chromium is reduced to Cr plus 3 in this reaction. Which equation is correct? We can see that in all the equations, zinc atoms are oxidized to zinc plus 2. Now let's look into the balanced chemical equations. The atoms should be balanced and the charges should also be balanced on both sides of the equations. In the first one we have 2 chromium balanced, 7 oxygens is also balanced, zinc is balanced, and 14 H plus and 14 hydrogen on this side. So number of atoms is balanced. Now let's look into the charges. We have -2 charge and 14 H positive, so it means plus 14 charge is also present. So -2 and plus 14, it becomes plus 12 on the reactant side. Now let's look into the charges on the product side. We have 2 chromium, which makes plus 6 charge, and this is plus 2. So in total we have plus 8 charge on the product side. So plus 12 charge is on the reactant side and plus 8 charge is on the product side, so therefore charges are not balanced. Now looking into part B, we can see that chromium is balanced. We have 2 atoms of chromium on both sides, 7 oxygens, 7 oxygen in water. Zinc is 1 and we have 3 zinc atoms present on the product side, so zinc are not balanced. In third one we can see we have 2 chromium, 7 oxygen, again 7 oxygen in water, 3 zinc, 14 H plus or 14 hydrogens on the product side. So atoms are balanced. Now let's look into the charges. We have -2 and we have 14 H plus. So net charge will be plus 12. Now let's look into the product side. We have 2 chromium plus 3. So we have plus 6 charges for chromium and 3 zinc plus 2. So plus 6 for zinc. So in total we have plus 12 charge on the product side. So the charges on the reactant and product side are balanced. Now let's look into the part D. We have 4 chromium atoms and we have 2 chromium atoms on the product side. So atoms are not balanced. So the equation in which both atoms and charges are balanced is C. Question 10. The equation shows that hydrogen gas and iodine gas react to form an equilibrium mixture. This is the equilibrium reaction and the enthalpy change is -9.6 kilojoules per mole. A mixture containing equal amounts of hydrogen gas and iodine gas is made at temperature T1 and the composition of mixture is monitored. A graph of these results is shown. This is mole fraction of iodine. The experiment is repeated at lower temperature T2. Which new graph would be obtained? Now mole fraction can also be considered as the concentration or the amount of reactant iodine, as this is exothermic reaction. So for exothermic reaction we know that at lower temperature the equilibrium moves in the forward direction. So when equilibrium will move in forward direction, what will happen that the mole fraction of iodine will be reduced. And second thing is that when we are reducing the temperature, the speed of reaction will also decrease. So initially this much time was taken to attain equilibrium. Now at reduced temperature, more time will be taken to attain the equilibrium. And initially we had 0.23 moles of iodine left at equilibrium. Now it should be less than that as the reaction is moving in the forward direction. Let's look into the options. We can see in part A, same mole fraction is given or same amount is present. In part B, we can see that the amount has reduced and time has also increased. So A is incorrect, B could be correct option. In part C, again we can see that the mole fraction is same or amount is same, which is incorrect. And in part D, amount has actually increased, which is not true for forward reaction, this is true for backward reaction. So according to our observations, mole fraction of iodine should be reduced. It has reduced. And speed of reaction has decreased, as initially it was somewhere here and now time has moved forward. So therefore answer is part B. Question 11. The diagram shows the Boltzmann distribution of energies for a reactant gas. For a particular reaction, the activation energy is X. It is given in the diagram. Which change to the diagram occurs if an effective catalyst is added at the same temperature? If temperature is same, the shape of curve will be same. So the peak will neither move to the left nor move to the right. Second thing is the addition of catalyst. Now what happens that catalyst only decreases activation energy. So now more molecules will be able to convert into the products. A is more particles will possess higher values of E. Catalyst does not provide energy to the molecules. This is wrong. D, the value of activation energy decreases. This could be the correct one. Correct answer is therefore D. Question 12. Which element requires the least number of moles of oxygen for the complete combustion of 1 mole of its atoms? Let's write the balanced equation for the combustion of all these in the presence of oxygen. First one is aluminum. Aluminum plus oxygen, it forms aluminum oxide. Magnesium, it forms magnesium oxide. Phosphorus forms phosphorus oxide. Then we have sodium, it will form sodium oxide. Let's balance these equations. We have aluminum oxide, so we can convert this odd number into even number by multiplying with 2. So 6 atoms of oxygen are there. Now we can convert this into 6. We have 4 aluminum, as now it is balanced. For magnesium, we need to add 2 and 2. For phosphorus, we have 10 oxygen atoms, so it becomes 10 and 4 phosphorus atoms. For sodium, we have odd number of oxygen atoms on the product side, so we can convert it into even by adding 2. Now this is 2, it is balanced. 4 atoms of sodium are present. Now we have to find out the number of moles of oxygen for 1 mole of reactants, which is aluminum, magnesium, phosphorus or sodium. Now in the first one we can see we have 4:3 for aluminum and oxygen. So if aluminum is 1, then oxygen will be X. By cross multiplying we can find the value of X. X is equal to 0.75 moles. Similarly for magnesium and oxygen, we have 2:1. So it will be 1:X. So X is 0.5 moles. For phosphorus and oxygen, the ratio is 4:5. So it will be 1:X. By cross multiplying, X equals 1.25. Now last one is sodium and oxygen. The ratio is 4:1. So 1:x. By cross multiplying, the value of x is 0.25. So among these four, we can see that the least number of oxygen molecules is present in part D. So therefore answer is sodium. Question 13. An element Y reacts according to the following sequence. Y burns in oxygen to form white solid, then it reacts with HCl to form solution, again sodium hydroxide to form white precipitate, and excess of sodium hydroxide to form solution. What could be element Y? First step is burning in oxygen to form white solid. Sodium forms sodium oxide, magnesium forms magnesium oxide, aluminum will form aluminum oxide, and phosphorus will form phosphorus oxide. All these are white solids, so therefore step 1 is true for all of them. In step 2, now the oxides react with HCl to form solution. Solution means it should be soluble. Sodium oxide will form sodium chloride, magnesium oxide will form magnesium chloride, aluminum oxide will form aluminum chloride, and this will form phosphorus chloride. All chlorides are also soluble, so step 2 is also true for all of them. Third step is the reaction with sodium hydroxide to form white precipitate. Now sodium hydroxide is formed when Na positive react with OH negative. So this is aqueous, no precipitate is formed. Magnesium hydroxide is white precipitate. Aluminum hydroxide is also white precipitate as it is insoluble. Now PCl3 reacts with sodium hydroxide to form Na3PO3, trisodium phosphate, which is soluble. Now we only have two white precipitates, one is magnesium hydroxide, one is aluminum hydroxide. Among these two white precipitates, in excess of sodium hydroxide, magnesium hydroxide does not dissolve to form solution, while aluminum hydroxide does dissolve to make solution. Correct option is therefore aluminum. Question 14. In which list are all three compounds soluble in water? We have chlorides, carbonates, hydroxides of group 2 elements, and sulfates. For chlorides, we know that all chlorides are soluble except silver chloride and lead chloride. So barium chloride is soluble. For hydroxides of group 2, the solubility increases down the group. So it means barium hydroxide is soluble. Calcium hydroxide is insoluble. Magnesium hydroxide is insoluble. Now for sulfates of group 2, solubility decreases down the group. So barium sulfate is least soluble. And magnesium sulfate will be soluble. Calcium carbonate is insoluble. Strontium carbonate is also insoluble. Correct option is therefore C. Question 15. Anhydrous magnesium nitrate MgNO3 twice decomposes when heated, giving a white solid and a mixture of two gases X and Y. Y is oxygen. What is the ratio of mass of X to mass of Y. Let's write the balanced equation. We have decomposition of magnesium nitrate. Nitrate decomposes to form oxide, nitrogen dioxide and oxygen gas. Magnesium oxide is solid, so we have two gases, one is NO2 and one is O2. Let's balance this equation. Magnesium is balanced. We have two nitrogen atoms, so we can write 2 with NO2. We have 6 oxygen atoms on the reactant side and we have 7 oxygen atoms on the product side, so we can write half with this one to make it 1. Now oxygen is balanced. According to the question, Y is oxygen, so it means X is NO2. And the number of moles of NO2 to oxygen is 2:0.5 moles. Let's convert these moles into mass in grams. The formula is mass in grams is equal to number of moles into molecular mass. For NO2, the molecular mass is 14 for nitrogen, 32 for 2 oxygen. So it is 46. Number of moles is 2. 2 into 46 is 92 grams. So X is 92 grams. Similarly for Y, mass in grams is equal to number of moles into MR. Number of moles is 0.5. MR of oxygen gas is 32. So it comes equal to 16 grams. In the answers they have given 1 for mass of X. So we can take 1 instead of X and we can find the value of Y by cross multiplying. X equals 16 divided by 92, which comes equal to 0.174. It means if X is 1, Y should be 0.174. Correct option is therefore A. Question 16. In a series of 9 experiments to test the reactivity of halogens, an aqueous solution of each halogen is added to an equal volume of an aqueous solution containing halide ions. As shown in the table, we have aqueous chlorine, aqueous bromine, aqueous iodine, and it is reactive with sodium chloride, sodium bromide and sodium iodide. The 9 resulting mixtures are then shaken separately with an equal volume of hexane, which is non-polar solvent. The 9 tubes are left to stand so that the aqueous and organic solvents separate into layers. How many test tubes contain a purple upper hexane layer? Now if iodine is present, then what will happen that it will dissolve in hexane to form purple layer. Let's see which one makes iodine. In first experiment we have sodium chloride that reacts with chlorine, so therefore no product is formed, which is iodine. In experiment 2, sodium bromide reacts with chlorine. It will form NaCl and Br2. No iodine is present. In experiment 3 we have sodium iodide. Now this can react with chlorine to form sodium chloride along with iodine. So in experiment 3 iodine is formed. Now with bromine, sodium chloride, it does not react with bromine because bromine is less reactive as compared to chlorine and no iodine is present. Similarly, sodium bromide does not react with bromine as it is already bromide. No iodine is also present. In experiment 6 we have sodium iodide that can react with bromine. Bromine will displace iodine, so it will form sodium bromide along with iodine. So we can see that in experiment 6 iodine is also present. Now reaction of aqueous iodine with sodium chloride, there is no reaction because chloride is more stronger as compared to iodine. So still iodine is present in the solution. Therefore experiment 7 consists of iodine. In experiment 8, iodine and sodium bromide. Again iodine cannot displace bromide, but though iodine is present in the solution, so experiment 8 consists of iodine. Then we have experiment 9, sodium iodide and iodine. Again no reaction will take place, but though iodine is present, so therefore this will also show purple hexane layer. So in total we have 5 test tubes that will show purple upper hexane layer. Question 17. Z is a compound of sodium, chlorine and oxygen. It contains 45.1% by mass of oxygen. Z is prepared by reacting sodium hydroxide with chlorine. Which row shows the conditions used for the reaction and the oxidation state of chlorine in Z? We have two reaction conditions. One is cold dilute sodium hydroxide and second is hot concentrated sodium hydroxide. We can write both reactions. Chlorine with cold dilute sodium hydroxide. It can form sodium chloride, NaClO, sodium chlorate plus water. In second reaction with hot concentrated sodium chloride, the reaction will be like this. The product will be sodium chloride, sodium chlorate, NaClO3 and water. As it says that Z is a compound of sodium, chlorine and oxygen, it could be this one or this one. We have NaClO or NaClO3. Let's find the percentage by mass of oxygen in each. Now the atomic mass of sodium is 23. For chlorine it is 35.5. For oxygen it is 16. So percentage of oxygen is equal to atomic mass of oxygen divided by total atomic mass. Into 100. It comes equal to 21.47%. Similarly for NaClO3 we have 3 oxygen atoms, so 16 into 3 is 48. Divided by the total atomic mass 23 plus 35.5 plus 48 into 100. It comes equal to 45.1%. It means it is not NaClO, it is NaClO3. And NaClO3 is formed by hot concentrated sodium hydroxide. So therefore it should be either C or D. Let's find the oxidation state of chlorine in NaClO3. We have sodium, oxidation state is +1. We have chlorine. For 1 oxygen it is -2. For 3 oxygen it will be -6. Overall charge is 0. So chlorine minus 5 equals 0, or chlorine is +5. Correct answer is therefore D. Question 18. Which row is correct? We have shape of ammonia molecule and ammonium ion and bonds present in ammonia molecule and ammonium ion. Ammonia molecule is NH3. There are 5 electrons in the outermost shell of nitrogen, out of which 3 electrons are bonded to 3 hydrogen atoms and 2 electrons are present in the form of lone pair. Now the shape of this molecule is pyramidal structure. Now in order to make ammonium ion, this lone pair can be donated to H+, and the structure will be like this. We have now coordinate covalent bond with H+. The bond angle will be 109.5. Now this is tetrahedral structure. Now in ammonia molecule we have sigma bonds, all bonds are single bonds. In NH4 again we have no double bond present, so therefore all bonds are sigma bonds. Correct answer is therefore A. Question 19. The table describes two possible environmental consequences of adding too much ammonium nitrate fertilizer to the soil. Which row is correct? First one is increased plant growth in rivers. Second is photochemical smog. Now you should remember that plant growth requires nitrogen, which is absorbed in the form of nitrates present in the water through roots. So there will be increase in plant growth. Second thing is photochemical smog, which occurs in atmosphere or air due to the presence of nitrogen oxides. These are in gaseous form, not in aqueous or nitrate form, so therefore it should be incorrect. Correct option is therefore B. Question 20. Hex-2-ene can be made by the reaction shown. This is the chemical reaction. We have hex-2-ene that is formed. Which statement about this reaction is correct? Part A, we have CH3,3CO negative is behaving as a Bronsted-Lowry base. Now Bronsted-Lowry base is something that donates lone pair of electron, lone pair donor. In the diagram we can see we have CH3, CH3 attached with carbon, and oxygen with negative charge is donating a lone pair of electron. So therefore yes, it is behaving as a Bronsted-Lowry base. Now Bronsted-Lowry base can also be defined as proton acceptor. So when it donates the lone pair of electron to H, what will happen that H will be attached with oxygen and product formed is OH. Part B, CH3,3CO negative is behaving as an oxidizing agent. In the reaction we can see that we have this CH3,3CO negative and it is gaining H+. It is not gaining hydrogen, so gain of H+ in neither oxidation nor reduction. So this is incorrect. Part C, the carbon iodide bond breaks via homolytic fission. In homolytic fission, there is equal distribution of electrons on both sides, as we can see that iodine neutral has converted into iodide negative, which means that there is heterolytic fission, it is not homolytic fission. Part D, this is a hydrolysis reaction. In hydrolysis, actually water breaks the molecule. As we can see that no water is involved in this reaction, so therefore it is not hydrolysis. Correct option is therefore A. Question 21. Structural isomerism only should be considered when answering this question. Molecule X contains 3 carbon-carbon double bonds. 1 mole of X is reacted with 3 moles of HBr. The carbon skeleton is unchanged. How many different products are formed? As we can see that the molecule is symmetrical on both sides, so therefore we can draw 1/2 HBr can be added to double bonds in such a way that either hydrogen is added to first carbon and bromine to second carbon, or bromine can be added to first carbon and hydrogen to the second carbon. Let's draw this half part. We have double bond, this, then we have CH2, and then this alkene ring. Now let's add HBr to the double bonds. Either hydrogen will be attached to this bond and Br to this one, and double bond is converted into single bond. Or we can say hydrogen is attached to this carbon and bromine to this one, and double bond is converted into single bond. Second scenario is that hydrogen is attached to this bond, bromine to this carbon atom, and this one is reversed. Hydrogen will be here and bromine should be here. In third scenario, we can change the position of this bromine. Now bromine is attached on this side and hydrogen on this side, and we can have HBr, or we can exchange the position of bromine and hydrogen. Bromine on this carbon, hydrogen on this carbon, and these can be exchanged. As the molecule is symmetric, so therefore same thing can happen on the other side of the molecule. So we have 4 different isomers that are formed by the addition of HBr on the double bonds. So answer is 4. Question 22. Structural isomerism and stereoisomerism should be considered when answering this question. A colorless liquid C5H11Cl exists as a mixture of 2 optical isomers. When heated with sodium hydroxide in ethanol, a mixture of only 2 alkenes is formed. What could the colorless liquid be? Let's draw the structures. We have A, CH3, CH2. It is bonded to CHCl. We have 2 CH3, CH2. The molecular formula of this compound is C5H11Cl, and it says it should exist as a mixture of 2 optical isomers. Now we can see that this carbon that is making 4 bonds, we have 2 similar groups attached to this carbon atom, so therefore it cannot exist as optical isomer, because for optical isomers we must have a chiral carbon. Now chiral carbon is absent, so therefore A is incorrect. Let's draw the structure for B. We have CH3, CH2, then we have CH, Cl, CH3. As we can see that this carbon is bonded to 4 different groups, so therefore it will show optical isomerism. Let's draw part C. We have CH3, CH2, then we have carbon, Cl, and 2 CH3 groups are also attached. Again we can see that with this carbon atom, 2 similar groups are attached, so therefore it will not show optical isomerism. Let's draw the last one. We have CH3, CH, another CH3 is present with this CH, then again we have CH, ClCH3. Now looking at these carbon atoms, first carbon we can see that two similar groups are attached, so therefore this is not chiral. In second carbon we can see that all four different groups are attached, so therefore this can show optical isomerism. Second part is heating with sodium hydroxide in ethanol. What happens and that HCl will be removed in the form of sodium chloride and water. Now hydrogen from one carbon and chlorine from adjacent carbon, they are removed to form alkene. Let's do this reaction with the first one. Now we have chlorine with this carbon and this carbon is adjacent. So either hydrogen can be removed from this carbon atom or this carbon is also adjacent to this carbon, so therefore hydrogen is removed from this carbon atom. So double bond could come between these two or between these two. Let's draw both structures. We could have first one CH3, CH, double bond, CH, CH3. This is the first possibility. Or if double bond comes between these two carbon atoms, then the structure will be like this: CH3, CH2, carbon, hydrogen, double bond, CH2. This is the second possibility. In the question it says stereoisomerism should be considered. Stereoisomerism is present in carbon-carbon double bonds, which means it could either be cis or trans isomerism. Now we can see that with this carbon atom two different groups are attached. Again with this carbon atom, one is hydrogen, one is CH3, so it will show cis isomerism, it will also show trans isomerism. In this compound we can see that with this double bonded carbon atom similar groups are attached, so therefore it will not show cis trans isomerism, only this product is formed. So we have 1, 2 and 3 products that are formed. In the question it says only 2 alkenes should be formed, so therefore this is incorrect. Now let's do the same for part D. We have chlorine atom that will be removed from this carbon and hydrogen should be removed from adjacent carbon. Now we have this carbon that is adjacent and this carbon is also adjacent. So either double bond will come between these two or between these two. Let's draw the structures. It could either be CH3, C, double bond, C, H, CH3, CH3, or the double bond could come between these two carbon atoms. Now the structure will be like this. Now in both structures we can see that double bonded carbon atom is attached to similar groups. So only one product is formed. And in this situation again we can see that double bonded carbon is attached to two similar atoms. So one product is formed. In total we have two different alkenes that are formed. Correct option is therefore D. Question 23. When 2-bromo-2-methylpropane reacts with aqueous sodium hydroxide and alcohol is formed, which diagram describes the first step in the reaction mechanism? Let's draw 2-bromo-2-methylpropane. In propane we have 3 carbon atoms. On second carbon we have bromo, and also on second carbon we have methyl group. Now this is tertiary halogen alkane because the carbon attached with halogen is attached directly with 3 other carbon atoms. And in tertiary halogen alkanes, what will happen that in first step heterolytic fission takes place. This is the slow step. In heterolytic fission, the carbon-halogen bond will be broken and carbon will become positive and bromine will become negative. Now this can only happen when carbon is partial positive charge, as it is attached with electronegative bromine. Now the shared pair of electron is actually taken by bromine in heterolytic fission. So in first one, the electron pair goes to carbon, which is incorrect. In second one, the carbon halogen bond is broken and electron pair goes to bromine. This is correct. In third one, we have attack, which is incorrect because it is tertiary halogenoalkane, and in first step attack cannot happen. Again, D is also incorrect. Correct option is therefore B. Question 24. When an organic compound Q is treated with phosphorus pentachloride PCl5, fumes of hydrogen chloride are evolved. When Q is formed with acidified potassium dichromate 6, which is oxidizing agent, the solution turns green. What is Q? It says when Q is formed with oxidizing agent, the solution turns green. It means Q is further oxidized. Now we have aldehyde functional group, C double bond OH. This can be further oxidized with potassium dichromate to form carboxylic acid. In B, we already have carboxylic acid. Now this one cannot be further oxidized by potassium dichromate. In part C, we have secondary alcohol. Secondary alcohol can be further oxidized into ketone. And in last one, we have tertiary alcohol, in which 3 CH3 groups are directly attached to the carbon atom having OH group. So tertiary alcohol does not get oxidized. Now for the first reaction, treatment with phosphorus pentachloride, we have aldehyde. Now this aldehyde can react with PCl5 to form geminal dihalide product, and this is not in your A levels syllabus. 2Cl will be attached to this carbonyl carbon along with POCl3. No fumes of hydrogen chloride are evolved, so therefore A is incorrect. Now we have secondary alcohol, CH3, CH, OH, CH3. It can react with PCl5. Chlorine will displace this OH. And fumes of HCl gas are produced along with POCl3. Therefore, correct answer is part C. Question 25. Alcohol Y gives a yellow precipitate with alkaline aqueous iodine. It can be oxidized to give a mixture of products including substance Z. Now substance Z gives a red-brown precipitate with Phelan's solution. Which alcohol could be Y? Now the substance that gives a red-brown precipitate with Phelan's solution is aldehyde. The functional group is CHO or C double bond OH. In the question, we have alcohol functional group that are given. Now it says alcohol Y gives a yellow precipitate with alkaline aqueous iodine. Only that alcohol can give the precipitate which have CH3 directly attached with the carbon having OH group. Let's see which one has this group. First one is CH3, CH, OH, then we have CH, CH3 is the substituent, then CH2 and OH. Now we have OH attached to this carbon atom, which is further attached directly to two carbon atoms. So this is secondary alcohol, and secondary alcohol can be oxidized to ketone. While this carbon atom attached with OH is further attached directly with only one carbon atom. So this is primary alcohol and it can be converted into aldehyde. Also we can see that CH3COH is present. So therefore this will give a yellow precipitate with alkaline aqueous iodine. So A could be correct option. Let's draw part B. We have CH3, then carbon, OH, then another substituent CH3, then we have CH2, CH2OH. In this structure we have primary alcohol, so this will be oxidized to aldehyde, and on this carbon atom we can see that this is directly attached to three other carbon atoms, so therefore it will not give a yellow precipitate with alkaline aqueous iodine. We only need one CH3 group attached to this OH carbon. Let's draw the third one. We have CH3, CH, OH, then we have CH2, CH, again another OH group is present along with CH3. Now we can see that both alcohol groups are secondary alcohol groups, so both will be oxidized to ketone. Aldehyde is not going to be formed, so therefore this is incorrect. In part D, we have CH2, OH, then CH2, CH, again OH, CH2 and CH3. Now this is primary alcohol, it will be oxidized to aldehyde, which is substance Z. And with this carbon atom we can see that CH3 group is not present, instead we have ethyl functional group. So therefore it will not give yellow precipitate with alkaline aqueous iodine. Correct option is therefore A. Question 26. CH3, CH2, CO, CH2, CH3, which is ketone, reacts with hydrogen cyanide to form an organic product called a cyanohydrin. In cyanohydrin we have CN and we also have OH group. Which statement is correct? Let's do this reaction. We have CH3, CH2, C double bond O, CH2, CH3. Now hydrogen cyanide, we have Cn negative, which will attack this partial positive carbon. This bond is broken. Then oxygen will become negative and this oxygen will then attack another HCN to get bonded with hydrogen. Now the product form will be like this: CH3, CH2. We have Cn attached with this carbon and we have OH group. Part A, the cyanohydrin product has one chiral center. We can see that this carbon atom is present and we have two similar groups attached to this central carbon, so no chiral center is present. Part B, the cyanohydrin product is formed by electrophilic addition. Now we have Cn negative, which is attacking nucleus, so this is nucleophile, and such type of addition is nucleophilic addition. Part C, the cyanohydrin product is formed via an intermediate which contains a COH group. This is incorrect because the intermediate that is formed is not COH, it will be CO negative. This oxygen will then attack another HCN to form OH. Part D. The formation of cyanohydrin product requires the use of cyanide ion as a catalyst. This is true because we need trace of NaCN to start this reaction, and sodium cyanide aqueous will provide Cn negative, and these are required to attack this carbonyl carbon. So this will act as a catalyst. Therefore, correct option is part D. Question 27. Reduction of compound R with lithium aluminum hydride gives the compound 4-methyl-pentane 2,3-diol. What could be the identity of compound R? In compound R, we can see we have ketone functional groups, aldehyde functional group, ketone functional group, again ketone functional group, aldehyde, and ketone. Now ketone is reduced by LiAlH4 to form secondary alcohol, while aldehyde functional group is reduced to primary alcohol. Let's draw the structure of 4-methyl-pentane 2,3-diol. In pentane, we have 5 carbon atoms. 1, 2, 3, 4, 5. On 4th carbon, we have methyl group that is attached. On 2nd and 3rd carbon atom, we have 2 alcohol groups. Let's reduce first one. We have CH3, then carbonyl carbon, then carbonyl carbon, then CH and 2 CH3 groups. This is reduced to secondary alcohol. This will be reduced to secondary alcohol. And this will remain unchanged. So now both are similar. It means A could be correct option. In part B, we have first aldehyde, which is converted into primary alcohol upon reduction. This will be converted into secondary alcohol. Rest is same. These are different. So B is incorrect. Similarly, in C, we can see we have 2 alcohol groups. There are secondary alcohol which are formed upon reduction. Again, this is different, so C is also incorrect. Now making D, aldehyde to primary alcohol. Then we have substituent. Then we have secondary alcohol from ketone. Again, this is also different. Correct option is therefore A. Question 28. Citric acid is found in lemon juice. This is the structure of citric acid. We have carboxylic acid group, we have alcohol group, again carboxylic acid group and carboxylic acid group. Which volume of 0.4 mole per decimeter cube sodium hydroxide solution is required to neutralize a solution containing 0.005 moles of citric acid? Let's write the chemical equation with sodium hydroxide. Acid plus alkali form salt and water. Now sodium salt will be formed upon carboxylic acid functional groups. We have 1, 2 and 3 positions. It would be like this: CO2, CH2, then we have COH, then CO2H, then CH2, and again CO2H. Now instead of hydrogen atom, sodium will be formed as it is salt. Acid plus alkali form salt along with water. Now as we can see that 3 sodium atoms have replaced 3 hydrogen atoms, so it means 3 number of moles of NaOH will be required. And also 3 water molecules will be formed. This is because now we have 6 hydrogen atoms, 1, 2, 3, and these 6 hydrogen atoms on the reactant side and 6 hydrogen atoms on the product side. Now we can see that the ratio of citric acid to sodium hydroxide is 1:3. Now for 1 mole of citric acid, 3 moles of sodium hydroxide are required. So for 0.005 moles of citric acid, X moles of sodium hydroxide will be required. By cross multiplying, we can find the value of X. It is 0.015 moles of sodium hydroxide. Now we have moles of sodium hydroxide according to the formula of concentration. Concentration is equal to number of moles divided by volume in decimeter cube. We have concentration of sodium hydroxide, we have moles of sodium hydroxide. Now we can find the volume. Rearranging this equation, volume is equal to number of moles divided by concentration. Let's put the values. Number of moles is 0.015. Concentration is given 0.40. And volume comes equal to 0.0375 decimeter cube. They have given answers in centimeter cubes, so we can convert this decimeter cube by multiplying it with 1000. So it comes equal to 37.5 centimeter cube. Correct answer is therefore C. Question 29. The structural formula of an ester is this. We have ester functional group. This ester is boiled with aqueous hydrochloric acid. So acid hydrolysis will take place. Which two products are formed? Let's draw the structure of this ester. We have two CH3 groups attached with CH. Then we have OCO. Then CH2 to CH3. Now you should remember that whenever acid hydrolysis of ester takes place, what happens that carbon-oxygen bond is broken, and the side on which carbonyl carbon is present, it forms acid, while the side on which oxygen is present, it forms alcohol. The products will be like this. We have CH3, CH, alcohol, OH, and second product will be acid. Now let's name these two. We have 1, 2, 3 carbon atoms in the long chain, and on second carbon atom we have alcohol. So for 3 carbon atom we use propane, and as on second carbon we have alcohol, so it is 2-ol. So we have propane 2-ol. Similarly, naming this one, we have 1, 2, 3, 4 carbon atoms in the long chain, so it is butanoic acid. Correct answer is therefore B. Question 30. The infrared spectra of 3 organic compounds are shown. What could the 3 compounds be? We have only 3 options. One is propanoic acid, which is carboxylic acid, one is ketone, propanone, and one is secondary alcohol propane 2-ol. Let's look into the first one. We have carbonyl peak present. So it means it could either be ketone, propanone, or carboxylic acid, propanoic acid. So spectrum 1 could be propanone or propanoic acid. Now in spectrum 2, it should be either propanone, propanoic acid, or propane 2-ol. Let's see which one is present. Again, in spectrum 2, we can see carbonyl peak is present. Also, OH peak is also present, OH. So when both carbonyl and OH peaks are present, it means it is carboxylic acid or propanoic acid. So ketone is absent as we have both C-double bond O and OH group. Propane 2-ol is also not possible. Let's look into the third spectrum. Carbonyl peak is absent. Only OH peak is present. So therefore it means it is alcohol. It is not propanoic acid, it is only alcohol. Correct answer is therefore B. Question 31. Which changes can be used to measure the rates of chemical reactions? First one is the decrease in concentration of reactant per unit time. We have both things. We have decrease in concentration and we also have time, so we can find out the rate. Second thing is the rate of appearance of a product. Again, we can calculate the time that is taken by the product to appear. So this can also be used to find rate. Third is the increase in total volume of gas. Again, this is change in the volume per unit time at constant pressure, so it can also be used. All 3 options are correct. Answer is therefore A. Question 32. Iron reacts with steam to produce hydrogen and oxide of iron. This is the chemical reaction. We have reversible reaction. A system containing all 4 substances is at equilibrium, which changes will decrease the mass of iron present at equilibrium. Now decrease in mass of iron means the reaction should move in forward direction. First is the addition of steam at constant pressure. If we add more steam, so we are actually increasing the reactants. The reaction will move in the forward direction and amount of iron will be reduced. So this is true. Second, to increase in overall pressure, as we have 4 moles of gases on the reactant side and 4 moles of gases on the product side. So by increasing in pressure, the equilibrium will neither shift in forward direction nor in backward direction as the number of moles of gas is same. Part 3. Addition of an effective catalyst. Again, catalyst does not change the position of equilibrium, it only reduces the time to attain equilibrium. As only first option is correct, therefore answer is D. Question 33, ethylene glycol, we have CH2CH2 and two alcohol groups, is used as a de-icer. It allows ice to melt at temperatures below 0 degrees centigrade. Which statements are correct? According to the question, it means that it decreases freezing temperature. First one, ethylene glycol disrupts the extensive network of hydrogen bonds in ice. Now we know that in ice what happens, that 6 water molecules, they arrange themselves in such a way as to make a hexagonal structure. And there is empty space due to which ice floats on water. Now ethylene glycol has OH bonds in which hydrogen is partial positive, oxygen is partial negative. So therefore ethylene glycol can disrupt the hydrogen bonds in ice and it can make hydrogen bonds with ethylene glycol. Now this is the reason that the freezing temperature is further decreased. Part 2, ethylene glycol molecules form hydrogen bonds with other ethylene glycol molecules. Obviously this can happen because for hydrogen bonding we need electronegative element like oxygen and electropositive hydrogen. So yes, it can make hydrogen bond with other ethylene glycol. Number 3, ethylene glycol molecule will dissolve in the water formed from the ice. As we know that the freezing temperature is decreased and we know that impurity can decrease the freezing temperature. Now ethylene glycol, it behaves as an impurity, so it dissolves in water to make hydrogen bonds with water. This is also true. All three options are correct, therefore answer is A. Question 34, which molecules contain at least one unpaired electron? Let's look into the structures. We have NO, nitrogen has 5 electrons in the outermost shell, oxygen has 6 electrons in the outermost shell. So we have 5 electrons in nitrogen, 6 electrons in oxygen. Now in total we can see that we have 11 electrons. It means 10 are paired. And only one is left, that is unpaired. So one is correct. Second one is NO2. Again nitrogen, 5 electrons in the outermost shell, oxygen has 6 electrons. These are the electrons of nitrogen. These are the electrons of oxygen. All electrons are paired except this one, so therefore there is one unpaired electron that is left, so this is also true. Third one is ammonia. We have NH3, nitrogen and 3 hydrogen atoms. Each hydrogen has 1 electron in the outermost shell. As we can see that we have 8 electrons, all of them are paired, so there is no unpaired electron that is present in NH3. As option 1 and 2 are correct, answer is therefore B. Question 35, which elements form a chloride in which both covalent bonding and coordinate covalent bond, which is dative covalent bond, are present? First one is aluminum. Aluminum can form AlCl3, which can exist in the form of dimer Al2Cl6. Silicon forms SiCl4. Magnesium forms MgCl2. Now in magnesium chloride, magnesium is metal, chlorine is non-metal, so therefore covalent bonding is not present. It is ionic bonding that is present. In silicon chloride, we have 4 electrons in the outermost shell of silicon that are shared with 4 chlorine atoms. So only covalent bonding is present. There is no coordinate covalent bond. Third one is Al2Cl6, which is in the form of dimer. We have 3 chlorine atoms with 1 aluminum. 3 chlorine atoms with other aluminum. As aluminum is from third group, it has 3 electrons in the outermost shell. Now it has bonded with 3 chlorine atoms to make 6 electrons in outermost shell. Still outermost shell is incomplete because outermost shell must consist of 8 electrons. So what happens that this chlorine will share its lone pair with this aluminum to make it stable. Similarly, this aluminum also has 6 electrons in its outermost shell now. So this chlorine will give one lone pair to make a coordinate covalent bond. So both covalent bonding and coordinate covalent bonding is present in aluminum chloride. As only option 1 is correct, therefore answer is D. Question 36. Which statements about calcium oxide are correct? Number 1. It can be reduced by heating with magnesium. Now magnesium is more reactive than calcium, so therefore this reaction cannot occur. This is incorrect. Part 2. It is produced when calcium nitrate is heated. Now when nitrates are heated, what happens that they form oxides along with nitrogen dioxide and oxygen gas. As calcium oxide is formed, so this is true. Part 3. It reacts with cold water. Now, calcium oxide can react with cold water to make a solution of calcium hydroxide. As option 2 and 3 are correct, answer is therefore C. Question 37. A diketo acid is a compound with 2 ketone groups and 1 carboxylic acid group. We have limonene and terpinolene. Which statement about the reactions of limonene and terpinolene are correct? Number 1. When reacted with an excess of hydrogen and nickel catalyst, limonene and terpinolene produce the same compound. Now what will happen that in the presence of nickel, hydrogen will get attached to double bonded carbon atoms, so alkene is converted into alkanes. Also we can see that the double bond will be converted into single bonds. So yes, we can say that the product is same. Part 2. An excess of hot concentrated acidified KMnO4 reacts with limonene and with terpinolene to form different diketo acids. Now hot concentrated KMnO4, it breaks double bonds to form different products. If the carbon involved in double bond is attached to 2 alkyl group, it will form ketone. If the double bonded carbon atom is attached with 1 alkyl group and 1 hydrogen, it is first oxidized to aldehyde and then further oxidized to carboxylic acid. If the double bonded carbon is attached to 2 hydrogen atoms, it will be converted into CO2. Let's look into the structure. In limonene, this carbon is attached to two alkyl groups, so it will be oxidized to ketone. This is ketone. This carbon atom is attached to one alkyl group and one hydrogen, so it is oxidized to carboxylic acid. Rest will be the same structure. Now this double bonded carbon is attached to two alkyl groups, so therefore it will also make a ketone. And this carbon is attached to two hydrogens, so it will make CO2. Now doing the same for second one, this will form ketone, this will form carboxylic acid. This carbon making double bond is attached to two alkyl groups, so it will also make a ketone. This carbon atom is attached to two alkyl groups, so it will also make a ketone. As we can see that the diketo acid formed in both are different, so therefore this is correct. Part 3. The reactions of limonene and terpinolene with an excess of Br2 produces positional isomers with the same number of chiral carbon atoms. What will happen when bromine is attached is that the double bond is converted into single bond and each double bonded carbon will gain one bromine atom. Let's draw the structures for limonene. Double bond is converted into single bond. This double bond is also converted into single bond. Similar is for terpinolene. Now instead of double bonds, what will happen that each carbon will gain one bromine atom. So one bromine is attached to this carbon, one bromine will be attached to this carbon. Similarly in terpinolene, Br. These two carbon atoms will also attach one bromine each. Now let's look at the chiral carbons. Let's first draw hydrogen atoms. We have 3 hydrogen present with this carbon. No hydrogen is present on this carbon. 2 on this, 2 on this, 2 on this. 1 hydrogen atom on this carbon. 3 hydrogen atoms with this carbon. 2 hydrogen atoms with this carbon. Similarly 3 with this. No hydrogen atom on this carbon. 2 with this, 2 with this one, 2 with this one, no with this one, 3 on this one, 3 on this one. And 1 will be present over here. Now you should remember that the carbon atom attached with 2 or more than 2 hydrogen atoms is never chiral. So we are going to look at only those carbon atoms that consist of 1 hydrogen atom or 0 hydrogen atoms. So this carbon is chiral. This carbon is chiral as these are attached to 4 different groups. This carbon is also chiral. This carbon is also chiral. Similarly on this side we can see this carbon is chiral as it is attached with 4 different groups. This is also chiral. This is also chiral. And this carbon is not chiral because it is attached to similar CH3 groups on both sides. This is similar to this one. Now we have 4 chiral carbons in limonene and 3 chiral carbons in terpinolene. So it says same number of chiral carbon atoms are on both groups, so therefore this is incorrect. As option 1 and 2 are correct, answer is therefore B. Question 38. One molecule of do-decane C12H26 is cracked, producing three product molecules X, Y, and Z. X is a straight chain alkane, Y and Z are straight chain alkenes with different molecular mass values. Which statement about X, Y, and Z are correct? We have do-decane C12H26. It is cracked to form X, Y, and Z. In one it says if Y and Z are but1-ene. Now but1-ene means it is C4H8, and ethene, which means it is C2H4. Let's draw this one, C4H8, C2H4. This is Y, this is Z. X will be hexane. Let's count the number of carbon atoms. We have 4 plus 2, 6 carbons. So out of 12, 6 will be left, C6. We have 8 and 4, 12 hydrogen atoms. So out of 26, 12s are lost. So we have 14 hydrogens. Now C6H14 is, the name is hexane. So therefore option 1 is correct. Part 2, if X is butane, butane is C4H10, then Y and Z could both show cis-trans isomerism. Y and Z are alkenes, so we have 8 carbon atoms left and 16 hydrogen atoms are left, so we can make 2 alkenes. We cannot make both alkenes with same number of carbon atoms because both have different molecular mass values. So if we are going to make one as 3 carbon alkene, C3H6, second will be C5H10. Or we can also divide this in such a way that we have 2 carbon alkene, C2H4, and we have 6 carbon alkene on the second side. These are Y alkenes and this is Z alkene. Let's find out whether Y can give cis-trans isomerism. In Y we have C3H6. The structure will be like this. Or Y could be C2H4. As we can see that double bonded carbon is attached to similar atoms, so therefore it will not show cis-trans isomerism. Similarly, double bonded carbon is attached to similar hydrogen atoms, so this will also not show cis-trans isomerism. So this is incorrect. Part 3, X could be octane. If it is octane, then it will be C8H18. We have 4 carbon atoms left. 12 minus 8 is 4. 26 minus 18 is 8. Now out of this we have to make Y and Z 2 alkenes. As we know that we cannot make 1 carbon alkene, there must be at least 2 carbon atoms for the alkene, so we can make C2H4 and again C2H4. This is not possible because the molecular masses should be different for both Y and Z. So this is incorrect. As only option 1 is correct, answer is therefore D. Question 39. Which statements about chlorofluoroalkanes are correct? Now in chlorofluoroalkanes we have alkanes and we have chlorine atom or fluorine atom attached with carbon atoms. Both the CCl and CF bonds are readily dissociated by UV light. Now this is incorrect because only CCl bond are converted into radicals. CF bond is stronger, it is not dissociated by UV light. Number 2, they have caused ozone depletion. This is true because chlorine free radical, they can destroy ozone to convert it into oxygen. Part 3, they are relatively chemically inert. This is also true because carbon chlorine and carbon fluorine bonds are also strong. We also have carbon hydrogen bonds in chlorofluoroalkanes. So these are chemically inert bonds. As option 2 and 3 are correct, answer is therefore C. Question 40. Which reactions of propane 1-ol have water as one of the products? Propane 1-ol is CH3, CH2, CH2OH. Number 1. Passing propane 1-ol vapor over hot aluminum oxide. Now this can remove water. OH from one carbon and hydrogen atom from second carbon is removed and alkene is formed. Number 2. Mixing propane 1-ol with warm ethanoic acid and a few drops of concentrated sulfuric acid. Now alcohol and carboxylic acid, they can react together to form ester along with the removal of water. We have propane 1-ol. Now this can react with ethanoic acid, which is C double bond OOH. What will happen that water is removed and ester is formed. So this is also true. Third one, warming propane 1-ol with HBr. This is propane 1-ol, we can warm it with HBr. And what will happen that this bromine will displace this OH in nucleophilic substitution reaction. And this OH and this hydrogen will make water. The product is like this, CH3, CH2, CH2. Now we have Br instead of OH. And this OH and this hydrogen will make H2O. All three options are correct. Answer is therefore A. Thanks for watching. If this was useful, please do like, subscribe and share.